So the big picture for this lesson is probability of independent events and dependent events. So two events are independent if one occurrence has no effect on the other. So let's say you're rolling a six-sided die. And let's say you roll, so since it's a six-sided die, there's a 1/6 probability of each number. And so a die is fair, it's completely random. So let's say your first roll is a 4. Does that have an impact on your next roll? Does that change the probability? Well, no, because the outcomes are still 1, 2, 3, 4, 5, 6, and they're all equally likely. So this is independent probability. The probability of each roll does not depend on the probability that came before it. So if you want to find the probability of two independent events, you just multiply each individual probability. So if I want to do the probability of 4 and then 4 twice in a row, that would be 1/6 times 1/6 equals 1/36. So what's an example of dependent? Well, the best example I can think of is with a deck of cards. Because you can talk about the probability of drawing a card, say probability of drawing a king, is 4 out of 52 because there are 4 kings in a deck of cards and 52 total cards. Well, what if you don't replace the king when you draw it? Then what's the probability of another king? So I would do probability of king, king, and no replacement. So the probability of the first king is 4 out of 52. But then if I draw that king, there are only 3 kings left and 51 cards. So I'd multiply these two together to find the probability of both those events happening with no replacement. So you can see how that's different than independent probability. If I replace the card each time, the probability is independent because I'm not changing the deck. But if I'm taking cards out of the deck or changing the sample space, that makes it a dependent situation. So that's the big picture for this lesson.